Greetings, specialists, and welcome aboard the SS King 304. I am Commander King, commander of this wonderful spaceship, and also chief scientist for the Alliance. Now, you have all been summoned here today because I and the Alliance have seen incredible potential in your scientific abilities, and we believe that you have what it takes to help humanity in these dire times. I'm sure you have all heard of the terrible news by now. 11.90 light years away, the planets Tau Ceti E and Tau Ceti F have fallen, and are now under control by Batarian forces. Experts, alien and humans, predict it is only a matter of time before war breaks out in Earth's solar system. Let me remind you that it was only 19 years ago that humanity encountered other intergalactic species. It is shocking then, in such a short amount of time, that other races have surpassed us in scientific knowledge, and humanity, this once proud and dominant race, is now on the verge of crumbling. As a result of this event, I have been selected to build a team of scientists, henceforth known as ACT, the Alliance Chemistry Team, in order to help close the gap between human scientific knowledge and the scientific knowledge of other alien races. This will be no easy mission. Our first mission will take us to New Delhi, India, where a mysterious bacterial disease has infected the area. It's uncertain whether this is an act of biological warfare, but regardless, the Galaxy Gazette has chronicled the devastation that has spread through the area. Let me make this clear. The universe's intergalactic species are keenly observing how we respond to this situation. This is in many ways a test to humanity's resiliency and ingenuity. Whether we as humanity survive or crumble will largely depend on your ability to solve important science-related problems and bridge the scientific gap between us and other alien races. May the sun shine brightly upon you all. King out. Good morning, everyone. My name is Jeffrey King. I am a science teacher at Camden County Technical School in New Jersey. And I am super excited today to share with you the science curriculum, chemistry curriculum that my students and I have been going through for the past 2 years. So this is kind of the second year. It's a work in progress, but I'm excited to share that. What you need to know about me and my school is that we are a technical school, meaning that all of our students are required to take 3 years of a career program ranging from culinary arts to information technology to carpentry and so forth, in addition to whatever requirements they need to graduate from New Jersey high schools. And most of my students come from Camden City in New Jersey. Anyone familiar with Camden City? Okay, when you think of Camden, what's Camden's reputation? Huh?
A lot of inner city.
A lot of inner city. Very inner city. Very diverse. It's consistently on the top most dangerous cities in the U.S. So that's the student base I'm working with, and I just want to give you a little bit of context because that's part of the inspiration for this. Those are the students I'm dealing with, but I love those students. I admire those students and what they go through every day and how they come to the classroom, and so I have nothing but good things to say about them. What you have just heard is how I start off my class on the very first day of school. That's the first thing the students hear from me. Before we get into that, I'm just going to go over the overview of the plan for today, or missions for today. The first, I'm going to talk about what inspired me to start this, what problems was I seeing in the classroom that made me think, hey, let's just write a space mission and go with it. And then we'll take a look at what this actually looks like in the classroom. So in other words, what does a lesson look like in this space epic? What does a single problem look like? And what does a unit look like? And what does the whole year look like? So I'm sure that's what you're interested about in seeing what it looks like. And I'm not here to say this is the best way to teach science or chemistry. I'm just saying it's one way. take it for what it is. All the evidence is in front of you. You might say, hey, that's great, I'm going to try some of that. You might say, that's not for me, and that's perfectly okay. But I'm just presenting the evidence, what I've seen, the changes in my students after I implemented this, and so you can kind of decide for yourself, hey, is this something I would like to do? And then finally, just a little bit of reflection. What do my students think? What do I think? And what's next? What I think is possible from this. So that's kind of the plan for going forward. All right. So I just want to take a quick poll. So I want you to imagine that you are your average student, or just pick any student that you think you have. All right. So you have a student in mind, and let's say on the very first day of school, they were greeted the way that I greeted you today. In other words, I stand out the door, I say, hi, I'm Commander King, welcome aboard the SS King 304, and what is your name? And they say, hi, I'm Jeff. And I say, okay, Jeff, what's your last name? And they say, King. And I say, Specialist King, welcome aboard. Please find your pod number on the holographic transmission screen, and then grab a seat and be ready for lunch. Okay? And then the next thing they hear is just what you've heard, which is, oh my God, we're in danger. Humanity is crumbling, and we need you to save humanity. All right, so picture that in your mind. Picture how you think your students would respond, and we're going to just kind of walk through the numbers here. So maybe you think your students are like, man, this is totally stupid. This is like the dumbest thing I've ever heard of. Are we in elementary school, right? Like where are we? Because I teach high school, right? So maybe that's something you might think. Or maybe you think your student would be like, oh my God, this is awesome. Like, this is what I've wanted to do all my life, is to save humanity. And maybe you're like, yes, 5, this is going to be great. And maybe you're a little bit skeptical, right? Maybe you think your student would be around a 3. Maybe like, well, I'm kind of excited, this seems kind of cool, but that guy up there, he's a little bit strange, and I'm not sure how this year's going to turn out, okay? So and then of course there are degrees. So let's just take like 10 seconds, picture yourself as your student, and we're gonna go starting with 5, and then go to 4, 3, 2, 1, and we'll just pull it down to 0, okay? Yeah? All right, okay, so take like 10 seconds, get over. Imagine you are your students. So, if you are super excited for this space mission, 5. Okay, we've got a few, we've got about 6 or so hands. If you're pretty excited, you're like, oh, this is kind of cool. If you're a little bit skeptical, you're somewhere in between, you're like, I need to see a little bit more from this guy. I'm not sure what he's trying to pull on me right now. Okay, if you're a little less, you're like, not enthused at all, yeah. And 0, this guy, I'm leaving, I'm out of here. Or I guess everyone has left who would have given this a 0. All right, okay. Okay, so all right. So this is kind of, I'm trying to get into my students' head a little bit, because prior to this, you know, I just did the typical thing in my first few years. I was like, hey guys, I'm Mr. King. It's great to meet you. Welcome aboard. Here's the syllabus. Look at all these awesome topics you're going to learn this year. You're going to learn nomenclature and empirical and molecular formulas and chemical reactions and stoichiometry and states of matter and all these wonderful things. And my students were like, yes, right? They're like, yes. Okay, so that's the problem I was running into. I was like, you know, when I think about science, this isn't what I want them to go home and think. I don't want them to go home and tell their mom, I learned gas laws today, because the conversation probably stops there, right? It's like, oh, gas laws. Oh, cool, I guess, right? So I wanted to go a little bit deeper. And another problem I was facing is with the problems I was giving students. So this is like, what would do science for, right? Like problems like this. But I was having a problem with, because I gave a lot of problems like these, and even though we want science to be inquiry-based, there is a role for just problems that we need to give students, and we need them to show that they understand certain concepts, right? And so I was really having trouble with problems like these, where, you know, this is a great problem if I want to know whether the students can solve for t, if they can solve for n, whether they can solve for v, right? This is a perfectly acceptable problem, and it would give me information about that. But it's not exactly exciting, right? And more importantly, if I solve for t and I get 25 Kelvin, well, what does that mean? If I get 700 Kelvin, what does that mean? In other words, there's no context to the problems I was giving. I was just asking them, for all I care about, I could have given them Sudoku problems, right? And they could have been using their brains in the same way. But that's what was frustrating me. I was giving a lot of problems like these. Now this was a little bit of a better problem because I've got that scuba diver, that's kind of cool. He's in the problem now, right? But I was still having trouble with this fact that even if they solve the problem for pressure, does it matter if the pressure is 7 atm? Does it matter if it's 1 atm? Does it matter if it's 0.3 atm? Do we care? Probably not, right? I don't know how it affects the scuba diver. I'm like, I solved this problem. I spent this time to show off my knowledge. And what do I have to show for it? A number. And that's it. I can't make any decisions off it. I can't do anything with it. And so that was frustrating me. So I was having a little bit of a crisis in my life, all right? And so I drew up, before I get to that, and I really thought about this, and I was thinking, well, why is that? Why am I giving these problems? And when we look at this textbook, or any textbook, this is a random chapter I pulled. It could have been any chapter, but you look at what takes up the majority of the table of the contents. It's content, 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 content. What's interesting about science? Oh yeah, if you have a little bit of time, if you have extra time, maybe you can throw something on about blood. Maybe you can throw something on about ocean acidification. These are like, I mean, just look at how this is oriented. It's like, this is important, and if you have time, maybe the context, you can squeeze that in a little bit, right? And so I was having this major crisis in my life. I'm like, whoa. And this is the analogy I would draw. Like, let's say you knew nothing about basketball. You don't know anything about the rules, the game, and I'm going to write a textbook about teaching you how to play basketball, which is probably the problem in the first place, but never mind that. But let's say I say one important part of basketball is shooting a free throw, right? That is an important part of the game. And so I'm going to teach you how to shoot a free throw, but to shoot a free throw, you need to do you need to hit these 4 standards. You need to be able to keep your eyes on the basket, and so I think, okay, how can I do that? Well, here's one problem. I'm going to tell the students to put their eyes here and look to the basket. And the second problem is they're going to start with their eyes here, and they're going to look to the basket. And so by the end of it, they're really good at looking at the basket, but do they know how to play basketball? Do they know how to shoot a free throw? I'm not sure, right? I'm not sure. And so I felt like I was zooming in so much on the content that I was missing the big picture. If this were basketball, I would be missing all the wonderful things that make basketball a fun game, that students enjoy about it, because I'm so focused on them mastering specific concepts, okay? I would be missing out all the different dynamics, all the different situations that would be coming up. So I was having this crisis a little bit. And so I was having this crisis, so when I went home, I just kind of binged video games, right? I was like, oh man, school sucks. I'm gonna play video games for 6 hours a day, all right? And so I was playing this game called Mass Effect. Just curious, anyone played Mass Effect? Yeah, okay, we got some. Anyone heard of Mass Effect? Okay, all right. So Mass Effect, but it doesn't matter if you don't know Mass Effect. Just think of a story or a book or a movie or a game that you were so immersed in that you spent like 6 hours, right? And you just couldn't stop doing that. You couldn't stop reading or you couldn't stop watching that TV series. What sucked me into Mass Effect was the story. And the fact that I felt like I was a hero, right? Like I had these choices. I was Commander Shepard of the SS Normandy, and I was like so cool. I was taking out aliens, and my decisions affected who lived and who died. So I could be like, I hate this person, so I'm gonna kill her. All right? I want to save this race because I think that race is awesome, so I'm gonna make my decisions to save that race. All right? And I was like, whoa, that's cool. And the other thing I realized is, like, I don't even like shooting games, and Mass Effect is at its heart like a shooting game. But I was like, I don't really care. This story is so immersive. You could tell me to do Sudoku problems, and I would do those problems to figure out the storyline, as long as I can continue making those decisions. And that's when I put 2 and 2 together. I'm like, wait a minute. That's what I need. I need a story that drives the learning of my students, that really gives them a choice and gives them a chance to make choices that affect the outcome of the class, essentially. All right? And so that's kind of what I was inspired by at the same time. So I'm going to get into some lessons very, very soon. I just want you to focus on 2 things during the lesson, because I think these are the 2 biggest pickups, the 2 biggest gains I've had after implementing. The first is immersion. My students are so immersed in the classroom. They care so much about the characters in the story. They'll ask me. And the other characters you'll see are just other teachers. And you'll find out that students like teachers more than they'll tell you, right? Obviously. And so, you know, they're like, oh my God, like,
like, Mr. Raymond, he's gonna die if we don't help him. All right, so we've got to solve this problem. Okay, and so they're really immersed in it. And the other thing is that my students, they want to help each other because they're all on this journey together, and they feel that sense of community. And my best example of this is a strange one, but I was walking through the hall one day in my school, and you have these students who, they act really tough and they act really cool. So there's this one girl in the center, and I wasn't sure how she would react if I said hi to her. But I do it anyway because that's what we do as teachers. We reach out and we take that first step. And she's surrounded by two of her friends, so they're just kind of like walking through the hall with the cool walk that they walk. And I walk up and I stop and I say, Specialist Gonzalez, it's great to see you. And she stops and she looks at me and she goes, Commander King. And the two students next to her, you should have seen their faces. They were like, what just happened? Right? It was like we had our own language. And that's part of the power of this, is that my students, they feel part of a team. They're proud to be specialists. They're proud to be part of the Alliance Chemistry team. They have pins at the beginning of the year that says, I am the part of the Alliance Chemistry team. And the language we use, students don't go to the assistant principal's office. They don't go to the APO. They go to the alien patrol office. We don't have to now. We have launch pads. We don't have exit cards. We have the landing pads. And so everything is partly made to immerse that student and make them feel like they're part of something bigger. And the final thing I would like to emphasize, that for me as a teacher, the biggest benefit of this is I am so good.
Teacher horn, it's fine.
I'm getting better. Yeah, I am getting better at incorporating cross-curricular activities, cross-cutting concepts, because think about it, rarely is a problem worth solving that can only be solved with chemistry, right? Like, there are very few problems where you can say, oh, I just need chemistry for this. Often you'll need a little bit of history. You'll need to write something. You'll need to investigate the career areas to figure out something if you're making metals or something like that. And so I hope you'll see that as we go through some of these lessons that it really brings opportunities for you to be creative and bring in other content areas. Okay, so here's our mission board for today. We got 5 important missions that we need to do. I'm not sure we'll get to them all, but we'll try. We've got 40 minutes. All right, so this might be doable. So the first thing about missions is I don't give topics, right? Because I told you at the beginning, like, who wants to learn about periodic trends? I headlined them with what we're actually doing. So this one, Commander Raymond, he's in a little bit of trouble. We got to save him. All right. For your sake, I've put in parentheses the topic that it would generally correlate to in chemistry. So this one's about dimensional analysis. Second one, packing gases for Mars, is one mission about molar conversions and how to make molar conversions a little bit more exciting decision-based. Taking back Saturn, Saturn's moon Titan, is a mission on stoichiometry and how that unit looks. So these are more kind of lessons, I would say, or 2 or 3 lessons, maybe days together. This is an entire unit, so we'll take a vote, but if you're interested in how this plays over in a unit, maybe this one's the one to vote for. Detecting toxic compounds on Earth is about empirical formulas, just a small lesson. Any Spanish speakers? We're in a little bit of trouble for that one, but if you're curious, choose that one. And the final one is mining asteroids, and that's about atomic theory and how we can use atomic theory to mine asteroids. All right, so think about it. We're just going to go through and take a vote, and I guess I'll try to count. So think about which mission appeals to you the most among these. All right, so take a second to do that, and I'm going to drink some water. Ready?
Yeah.
Anyone even time? No. Who wants to rescue Commander Raymond? All right, Commander Raymond isn't going to like you guys, but all right, Raymond. What happened here? Okay. How about packing for Mars? Molar conversions. Packing for Mars. We've got 1, 2, 3. So the same amount of people are going to pack for Mars. Let's say Commander Raymond. Taking back Saturn. It's probably this one. I'm going to say 15. All right. Detecting toxic compounds, 1. And how about mining asteroids? Anyone want to mine some asteroids? 4, 5. All right, so we'll start with this one, and then we'll go to mining asteroids. All right. Okay. So, so I'm going to start each unit with what typical problems look like. So typical problems in stoichiometry look something like this, right? And I've given problems like these before. I definitely have. The complete combustion of octane C8H18, the main component of gasoline, proceeds as follows. How many moles of O2 are needed to burn 1.50 moles of C8H18? Then B, how many grams of O2 are needed to burn 10 grams of C8H18? And then C, octane has a density of this. How many grams of O2 are required to burn 15.0 gallons of C8H18? And I think these problems are close to being where they need to be. But anyone have any complaints about that problem? Do we feel comfortable with that problem, giving that problem? I mean, it definitely assesses what they need to know, right? They definitely need to do stoichiometric calculations, and that's great. Yeah. Any of you want to find anything I'm missing about that? The excitement. The excitement, yeah, like the excitement. But more than that is what I've been really thinking about is if I get a number, can that number tell me about something I should do? Sorry, Jake. No? Okay. Can that number tell me something about what I need to do? If I calculate how many moles of O2 are needed to burn 1.50 C8H18, let's say it's 3 moles. I calculated it's 3 moles. I'm done, right? I'm done. And I don't really feel like I've accomplished anything. I figured out the number is 3, but I can't do anything with that number, right? I just think it's 3. And this one's a little bit better because we're making aspirin, right? And this equation's for aspirin, and kids have heard of aspirin, and that's wonderful, we're making aspirin. But even if I figure out how many grams, the kid might say, well, why am I making aspirin if I can just go to the store and buy it, right? So there are all these questions that students have, and so you've got to make it relevant. Maybe if you tell, for example, Commander Raymond, he's going to die if you don't give him aspirin. Maybe they'll do something about it. I don't know, but let's take a look. Let me take a poll. If you teach stoichiometry, how many of you start out with a food example? Like, to make a pizza, I need like 1 pie, 6 pepperoni, and 3 mushrooms, and then use that as a chemical reaction transit. Anyone use that method? Yeah, I do too. I think it's a fairly reasonable method, but, you know, well, the students always ask me like, wait a minute, we were just dealing with chemicals before, now we're dealing with pizza? Like, what happened? Are we in chemistry still? So I wanted a little bit more of a context. So here's the mission that I gave students. I apologize, they didn't give me an audio jack, and then when I called Eric with any questions, he said the convention center takes care of it. So I don't know, but I'll put the sound up and I'll put the microphone right next to it, and hopefully we can hear it. I think it should be good, but let me know if you can't hear it. Alright, so this is the mission where the Batarians took Saturn's moon Titan, and we're trying to fight back, and Chef Battaglia has a mission for us. He is the culinary teacher of our school. Come on, YouTube. Technology 200 years in the future, still terrible. Alright. The wireless got disconnected. Wonderful. We think we have better technology. We still use the English units, by the way, 200 years in the future. Just all these fun facts. So I do apologize for this. Let me just get this Wi-Fi back up, and this video should be good. All right, one more time. Okay, all right, I'm going to refresh this. This presentation is going to be on, it's on Prezi, so anyone can access it. I'll give you the link at the end so you can browse through the videos. It is a rather large file, as you see by this loading screen. It's mostly that background image that's taking up a lot of space. All right. Yay. Okay, so as we were saying, we're about to help Commander Battaglia see what, yeah.
here we go.
Dear ACT specialists, I'm the head chef for the Alliance military on our Mars outpost. With the loss of Saturn's moon Titan, many Alliance military members have been moved here to defend Mars. Of course, as a result, I'm working double time, lacking enough ingredients to produce enough food for all the troops here. But hey, that's just the way the cookie crumbles, and I have 2 requests for your team. Number 1, to feed the troops, I'm trying to make pepperoni and mushroom pizza. I have infinite amounts of tomato sauce, 1,250.5 kilograms of dough, 10.5 kilograms of pepperoni slices, and 1.25 kilograms of mushrooms. On each pizza, I use 1 crust, 12 slices of pepperoni, and 20 mushrooms. Please let me know how many pizzas I can make using these ingredients. If you need additional information, please just ask Commander King. I hear he's a smart cookie. Number 2, I need to feed 10,000 troops 1 pizza each for the next week. In order to do so, how many kilograms of dough, pepperoni, and mushrooms will I need? If you could calculate the amount of each, message to Chef Gordon Order, and then have him package the goods for me in express rocket mail, that would be as sweet as sugar. Piece of cake for you all, right? Though I hope war does not reach Mars, no matter how you slice it, we're in quite the pickle. I hope your team has something invented that's the best thing since sliced bread. Reports are coming in that we're going to need a massive burst of technological ingenuity to defeat these alien forces. I know you already have a lot on your plate, and if this would be too much work, don't bite off more than you can handle. Regardless of whether you can help me or not, I'll try to remain as cool as a cucumber until someone does save me my baby. Finally, please take down those Batarians. They're rotten to the core for what they did in New Delhi. I know the Alliance is putting all their eggs in one basket by entrusting so many important tasks to you all, but you guys have proven that you're worth your soul. By the way, if you're ever on Mars, feel free to stop by and chew the fat. I'll cook you all up something delicious. Now, if you'll excuse me, I have bigger fish to fry. The tag right now.
So the first question is, how many food-related videos and metaphors? But you can see there's a lot of fun you can have with this, and so this is a problem that we all give, right? We give similar problems like this, but it's just a little bit more meaningful to the students because there's a little bit of context to it. There's a little bit of story that goes on with it, and that's been doing wonders in my classroom. Just that little bit, you know? They could have read that problem in a textbook, and a lot of them would have shut down. But there's this situation here where they can now think about this. Someone needs it, and if we don't give Chef Battaglia his food, the troops are going to starve. And so we need to calculate that. And so, again, their answer is meaningful. And to make the answer a little bit more meaningful, you can attach a cost. So what sometimes I do is I say, you have $1 million. And can you buy all the ingredients with $1 million? And I think that's the easiest way to make anything relevant is just put a price tag on it. Oh, that takes 25 grams? How much is that going to cost? Do we have enough money? You have $500. Is that enough money? But it gets them thinking about whether their numbers make sense, and it gets them thinking about why numbers matter, rather than I got 7 grams, and that's it. So put a cost on things. That works pretty well, usually. All right. So we've helped Chef Battaglia, and after that I would just kind of do your typical instruction, right? Like, let's model through this problem, and okay, we figured out this. Now maybe you need to make like some ham and egg sandwiches. So, all right, you know, you need 2 slices of bread, and they practice and so forth. But it's all in context because Chef Battaglia needs it. And now let's slide on to the next part, which we are now helping Commander Brian.
Greetings, ACT specialists. I am Commander Brian of the SS Brian 208. To take back Saturn from those wretched Batarians, we have stealthily landed on Saturn's 6th largest moon, Enceladus. We will be preparing attacks on Titan in a month or so, but I need time to finalize some preparations here. Things have taken an unfortunate turn, however. On an icy moon like Enceladus, it should be difficult for bacteria to survive, but somehow, many of our members are exhibiting symptoms similar to those of the Black Death. Now, I'm sure you remember from world history what the Black Death was, but just in case you've forgotten, the Black Death was one of the deadliest diseases in the history of mankind, killing nearly 75 million people worldwide and 20 million people in Europe alone. Alright, pop quiz time. Let's see what you actually remember. If you can tell Commander King the symptoms of the plague as well as how the disease was spread, I'm sure he'd be happy to reward you with some team merit points. More urgent though, our troops need the antibiotics to stop the disease from spreading, and we need them quick. Losing our troops here would severely delay our ability to take back Saturn as soon as possible. I have the utmost faith in your team's ability to prevent a second Black Death, but remember that those who don't know history are destined to repeat it. Don't let history repeat itself. Right now.
So what caused, what was the question you asked? What caused Black Death? What
Symptoms.
symptoms? Was it symptoms?
Yeah.
Symptoms and also, yeah.
Symptoms and vehicle, right?
Right.
Okay. Anyone know?
Transmitted by rats,
Rats, right? The rat in the background.
and they had the welts
Yeah.
on their arms.
The black welts on arms, armpits particularly. Some pretty gruesome stuff. And that's something they learned in world history that I was able to pull back. I'm like, hey, I need to solve a disease, so why not the Black Plague, right? Whatever. We're on Enceladus. Who knows what happens there? But you do want to kind of put it in context. So Enceladus is cold, and we know, I think we know, that bacteria have trouble surviving cold. It depends, right? There could be
Extremophiles.
extremophiles, yes, absolutely. And so we want students to think about that as well. But again, it's a context that's there, and then, you know, we might have something where the students research a little bit about Enceladus. But what's the problem look like then? We say, hey, what do we do to treat the Black Plague today? Why doesn't the Black Plague exist anymore? Well, we've got these antibiotics like ciprofloxacin, I think that's how you pronounce it, and this is the part where it's a little bit iffy, but I'm okay with it, and maybe you wouldn't be okay with it, but I kind of just make up the reactants. In other words, I'm just saying, you know, yeah, we can use benzene, and, you know, NO, and hydrofluoric acid, and that's perfect. When we mix them together, and they just make ciprofloxacin, right? So maybe you're not okay with that, but, like, the student doesn't know any different. Like, if you gave them a real reaction at this point in their learning, for me, they wouldn't know. And so they're just really testing that skill. You're just trying to make them think about all they really know in chemical reaction at this point. They don't know anything mechanism-wise, right? Because that you need 2 years of college for. So I think I'm okay with making up ingredients, just so I can give them a context as to making something that might be useful, instead of giving a real reaction, but then we make like NaOH, and we're like, well, what do we do with this NaOH, right? It's already there. So, I don't know, something to reflect on. But then they calculated, a little bit of a typo there, but yeah, we're going to produce 250 milligrams generally. That might not be enough, that might be not the amount for one pill, because there's probably less, but okay, we have an amount. And so they have a reason to do it. And then to expand, this is what I'm talking about with the cost. Let's give them another alternative. What if we also can make doxycycline? Maybe some kid researches, hey, in addition to ciprofloxacin, we also use doxycycline. And again, we have these false ingredients, but whatever, that we're going to do for now. And then maybe we only need 100 milligrams of this. And the final question is, would it be cheaper to produce this than ciprofloxacin? And now you've got students needing to justify things. So even though these two problems, right, like you probably already give these problems anyway. But now they have to do a little bit of comparing. They have to do a little bit of justifying. And again, if you throw in that cost factor, again, you could actually research these values, right? I wasn't that rigorous with it, and I just kind of made these up based on how many atoms they had. But you could actually research that and say, hey, what does that look like? What are the actual costs of it? And really give students an idea of justifying which one is better. All right? I'm going to skip the next one. The next one is just on limiting reagents. Another teacher gives permission. But let's take a look at the assessment. So I'm ready to assess. I taught all these things in context. They had a bunch of missions. Maybe they had to make some other pharmaceutical drugs because some guy on Mars was having an issue with his leg or something. And so we're ready to assess. And so my assessments are like, I call them solo missions. They're not assessment. They're missions that you do by yourself. They're solo missions. And they're very, very, very stressful to the students because if the requirements are different every time. So I might say, all right, the class needs to average an 80% on this test for this mission to succeed. And if it doesn't happen, the mission fails and there are ramifications. People die, people lose arms, okay, whatever. And they don't want their teacher to lose an arm. And so there are different requirements that you give them. And so they're pretty nervous when they come into these tests. And for this one, you know, we're going to war on Titan, right? We're going to war on Titan, and this is NH4NO3, which is an explosive that they would use, and they have to design it. And there are two methods, and of course they need to pick the cheaper method because we're trying to make the cheaper method. All right, so that's all that is. It's kind of the same thing we saw earlier, but it's putting it into a context where this mission succeeding, our taking back Titan, is absolutely critical and dependent on the fact that we have enough explosives. Otherwise, we're going to shoot a little bit of explosives and we're going to get blown to pieces, right? The second mission part is Commander Brian, who you saw earlier. Well, his assassin team is in trouble. They took out 10,000 Batarians, and now they're running out of liquid hydrogen and oxygen to blast off because their fuel tank has been damaged. And so they've got a limited amount in here. They can produce a certain amount of energy. If they need this amount of energy to actually blast off, will they make it? And do we need to send in reinforcements to help them get off the planet? Okay, so it just kind of, they're solving the same problem, but there's a little bit of context here. There's a little bit of consequence as to what happened in the end. And then finally,
Commander O'Connor.
this is incorporating a...
In the next month, Commander Thurber and I will be leading an afternoon.
This is, they see this one day before the assessment, this video.
Alliance troops in Saturn's moon Titan against the evil Batarians. Currently, experts across the galaxy claim that we humans and the Batarians are evenly matched. But we can swing the tide if we use sarin, one of the deadliest neurotoxins known to humanity. Science Officer Cassiano has told me that sarin is lethal to all intergalactic races, even in the smallest amounts. People who ingest sarin die within minutes from lung muscle paralysis. The lucky ones who survive suffer permanent neurological damage. Sarin has a long and ugly history. In 1993, at the U.S. Chemical Weapons Convention, 162 countries agreed to ban sarin production and destroy existing supplies. Despite this ban, sarin was used later against the Syrian people during their civil war, killing over 300 people. Putting that aside, I think ACT should seriously consider developing sarin, again, to use against the Batarians. While we did sign an intergalactic ban in 2150, the present situation requires us to reconsider that ban. When war starts, every weapon at our disposal should be available. Sarin would give us a huge advantage in battles to come. Do you really think the Batarians are going to fight honestly? Ultimately, I leave the choice to you and Lieutenant Commander King. Remember, never was anything great achieved without danger. Live long and prosper. Alfano out. I made you Lieutenant Commander.
Yeah, he went off script a little bit, but that's okay. Okay. So what prompted me to make this mission was what was happening in Syria, right, where they were using sarin. I was like, oh, you know, sarin, that's kind of crazy. And so what I'm hoping to show here is that science, in many ways, can be a cure, and also very much a weapon. And maybe that shouldn't hinder us from, pursuing science, but that's something we need to take into consideration, that there is powerful weapons that can be made from sarin. And now I'm putting them into the role. They have to make a decision now. Do we use sarin, or do we not use sarin? And as this last question on the test, they have to do a calculation, and this last question here, in your opinion, should the Alliance use sarin gas to fight the Batarians? Explain your reasoning using any facts we talked about, or that you researched. So their homework assignment that day was to tell me something about sarin that I didn't know. Tell me something historically, or tell me an effect that I didn't know. And now, I'll be using your English teacher's rubric to grade that piece. And so I was able to incorporate an English portion, evidence-based writing, because I had the evidence there, this was an authentic situation, and I was able to pull that in. And so none of these things, all these historical things, I wouldn't have even thought of bringing in. I wouldn't have seen the connection if I didn't want to write a storyline. If I didn't create a story, it would have never occurred to me. So that's what I mean by this, I think, helps you think about how can I be creative and bring in other concepts from other classes, including writing, justifying things, and so forth. Okay. All right, so hopefully if the students got above an 80% on that, we saved Commander Brian. If he didn't, he lost a leg. We either used or didn't use sarin, which does not have an immediate effect
but will have an effect in a future mission. So depending on what they choose, there's a little bit of a split that they don't know about. They just know, hey, we used sarin, woohoo, we killed all the Batarians. And so down the line, that's going to come back to either haunt them or help them. What happens? Nobody knows until the end. All right, next mission was mining asteroids. Yes. Okay, let's mine some asteroids. All right. Oh no. Let's mine some asteroids. Okay. So we're having. Yes, sir.
I have a question.
Yes.
With this, when you were developing this, did
Yes.
you pretty much lay out the entire year from the first time you rolled this out, or did you kind of work it in a unit?
Yeah, it's a great question. The first year, so this is my second year doing it. The first year over the summer, I wrote probably the first 3 units for the year, I would say. And then it kind of died off a little bit, like as I was sputtering a little bit. I'm like, this is a lot of work. I can't do this. And so it kind of died out towards the end. And then this summer, I was able to really revamp it and add more. So you can do it a unit at a time. It might not be as immersive as doing a whole theme. But you know, you can say for this unit, we're going to mine asteroids, right? And that's totally fine. And then maybe next year you add in one more unit. We're going to take back Saturn and Titan. And then after that, you can piece it together. But yeah, I kind of did 3, tested it out. It was working great, but I didn't have the time during the year to complete it. And then so now I'm just kind of, this is by no means a polished product, but it's just in kind of ongoing, building each year type thing to the storyline. Yeah. Questions, feel free to ask. I know I have a tendency to get really excited about nothing, but if you have questions, please stop me. I don't mind. I'm perfectly happy to do that. All right. So my problem with this unit is atomic theory. Is we get problems like this where you just how do you assess whether a student can write electron configuration? How do you make that interesting? Like 1s2, 2s2, 2p6, right? Like, is there any way to do it besides saying, write the electron configuration or the shortcut electron configuration? So I really had to kind of rack my brain for this one. And also thinking about testing for the atom, like, you know, how many protons are in it. So that's 26 protons. Okay? And so this was a bit of a challenge, but here's how I ultimately came around to solve the first problem. Think about the first problem.
Morning, ACT Specialist. I'm Commander Reeve of the SS Reeve 204. One of my roles is to serve as the Communications Director for the Alliance Fleet. As Communications Director, I'm responsible for making sure that important messages are sent across the universe without being intercepted by alien fleets. Often, we encrypt our messages. Recently, hackers have been intercepting and decoding our messages that have been sent to our outposts on Kepler 22b. As a result, we've lost many transport ships because alien forces have been aware of our ship's movement. We need to find a more unique way to encode our messages. Commander King suggested using electron configurations to encode the messages. I have no idea what the heck that means, but it might be worth a try. I figure most people aren't very scientific, and we can use that to our advantage. I have transmitted the message I need to send to the Kepler 22b base to Commander King. He will further brief you on the details of the mission. Zu Funi, buena suerte, and good luck. Reeve out.
So one of the requirements to do this video is you have to have a cheesy closing line. Yeah, and the history teachers all have cheesy history quotes, so whatever. That's the mission. Had a little bit of fun with that. She's an English teacher at my school. Kepler 22b. Anyone know the significance of that planet? Yes? No? Raise your hand? No? Okay. Kepler is, it's from the telescope, the Kepler telescope, and this was one of the first planets they identified in the Goldilocks zone. In other words, not too far, not too close from its sun, so it might be able to have life on it because there's it's conditions for liquid water, and they think, hey, possibly there might be some simple organisms developed on there, but we're not sure. That's just hypothesis. But I kind of took that and say, you know, they could research that and figure out, hey, that's why we're using that planet. That's a real planet there. Kepler 22b. There are other ones too. I don't remember how many Kepler is found in the zone, and we do watch a video in class about like the Goldilocks zone and the Kepler telescope, so it's a neat application to that. But Kepler 22b is really neat, so if you haven't checked that out, it's pretty interesting. Okay, so this is the message that Commander Reeve wants me to send. It's a pretty standard war message. War is coming to Kepler 22b. I hope you're okay. The aliens have blocked off our asteroid supply. We need you to purchase weapons from far away. I had to stretch my imagination a little bit. This doesn't make sense. You know the keywords, cops, crooks, goons, boss, whatever. And that's the message. So we want to encrypt that message. And so what I did is I took that message and I say, let me try to write that message with the elements on the periodic table. And so what you see here is that encoded message. Here are the elements on the periodic table, H-I, M-O-B-Y, and so forth. And so what my students need to do is to encode this message. So please encode this message. You don't need to do it all. So if you're working in a team, you split that up. Each person has a part in that message. And that's, I don't know if you probably realize this, like, if you need to give kids 3 problems, give their group 10 problems, right? Because then they're like, oh yes, I only need to do 3, and they feel like they're getting such a good deal, but really you only wanted them to do 3. and so they don't know. So I like that topic a lot. It's giving them a sense of false choice, right? And it works in games so often. Like a lot of times your decisions in games, you make this game, you choose this dialogue path, and like the guy says the same thing, right? But you still feel like you kind of made a decision, okay? And so that's really powerful as well. And so they take that message and they, if this student had to write more years on, they would write the electron configuration for tungsten, they would write for argon, but they have a reason to write it, right? It's not just, hey, here's the answer, and their answer means something. It means they're going to send this message and are able to send the message. So that's what I'm constantly thinking about. I'm constantly thinking about, does my answer do something? And in this case, it's really a stretch, right? It's really a stretch. Electron configuration is about where the electrons are located. It doesn't give anything to that, but in terms of what I want, which is to give them, make sure they know that it's okay with me. For more kind of identifying the particles, I decided to identify identify different metals on asteroid planets. So there's this video here from Planetary Resources. They are a company. Anyone know what they want to do? Mine asteroids, yes, that's it. They want to mine asteroids. They think there's valuable metals on asteroids. In this video, they point out 2, platinum and water. Okay? They may be thinking, water? We kind of have water here. Anyone know what they want to use that water for?
Fuel.
Fuel, exactly. So water is the main fuel for rockets, liquid hydrogen, liquid oxygen, they combust. And so if they could get those components from water, so they could set up like a docking station on an asteroid so spaceships could pass by, land, restock. And so they have this nice video where it's so inspiring. There's like this inspiring music in the background. They're like, yeah, we're going to get billions of dollars from these asteroids. And so I show them that video and then have them think about, you think this is real? And they can think about the limitations and so forth and kind of justify what it is. But then I take a look at NASA's near-Earth object data, and NASA has all the data you want, but these are asteroids that are close to us. And for example, one asteroid you can find is titled SG344. I don't know how they get these names, but that's what they are. And I say, hey, I've detected on asteroid SG344 there are 3 elements. Element 1 has 28 protons. Element 2 has 1 electron in the outer ring and 3 total rings. So it's really testing their knowledge of the Bohr model. But in addition, I say, here are some valuable metals that Planetary Resources think we could pick off those asteroids. Rhodium, platinum, palladium, zinc. And I value them, I just give random points roughly based on their worth on the market. So I believe rhodium is the most expensive. I believe. Which is a little bit shocking because most students think it's platinum. I'm not sure if that's still true. I may have to readjust. But, and then we decide in the end, which asteroid do we go to? Because there are millions of asteroids out there, right? So which one are we going to go to? Well, we're going to go to the one that has the elements with the most points on it. So again, this is another divide and conquer. Here are 20 asteroids. Tell me which of the top 5 I need to go to. So hey, you get 6, I get 6. That person takes 6. We're going to reconvene afterwards. We're going to discuss what asteroids we're going to go to, and that's going to embed valuable resources into our bank account, which we can use to purchase, nuclear weapons to blow up the Asara or whatever. So that's kind of how I got around that. But asteroids are so fascinating. I'll get into that a little bit later. Asteroids are a super, super duper exciting piece of it. We're running out of time. But all of these are on here. If you want to look at them, I'll put the Prezi on at the end so you can look at the other 3 missions. All the videos are there, and so forth. Just a brief note, this one is in Spanish because we have a lot of students with Spanish background. And I love that one because you get that kid who doesn't talk all year because she's a native Spanish speaker, and is an ESL student, and suddenly she's the expert. She's like, oh my god, I get something in this class. I understand what he's saying or what someone's saying for once. And so it's great to see that student really step up and explain, hey, this is what's going on, and so forth. And the other ones are neat as well, but if you have the time, take a look. All right. Okay, I just want to end it this way. Here's what I'm really hoping for down the line that we think about in science, that we really put, instead of thinking about the content we want to teach, we think about what important problems do we want our students to solve. And I think that's a good way to put it. And maybe one of those problems, for example, could, how many of you saw Bill Nye yesterday? A lot of you. And he talked about the importance of the asteroid defense system, or at least knowing what's out there. But imagine this. Let's say our key thing we want students to learn is to be able to deflect asteroids, right? In case Earth is hit by an asteroid. And that's the unit heading. And there are so many resources out there. Like last year, there was the asteroid that hit Russia. There's the one that missed. You have lots of video with experts, Neil deGrasse Tyson, Bill Nye, that interview them about this process. New York Times wrote a ton of articles about this. And then this is my favorite one. So in the process of researching this, NASA has this 300-page report about what they've researched about asteroid detection and deflection. And it's actually pretty interesting if you have, a weekend, I don't know, to read through that. And they tell you all the different methods they use, the gravity tractor, a kinetic impactor. They actually had a mission, Deep Impact, to test what would happen if we launched this object into the asteroids and the effects of that. So that was awesome. There are all these resources out there. And what if you combine it into a mission like this? Like, the Batarians are targeting Earth by aligning asteroids. So in the future, come on, nuclear weapons? That's like 200 years old. We're using asteroids, and we're aligning asteroids to align them so they hit Earth, or they hit other planets, right? That's the weapon. These asteroids in space, these millions of asteroids are going to readjust and hit your planet. So that's the situation. Well, what are we going to do? We first got to figure out what's on the asteroid. So I'm going to need my chemistry to do that. I may need some atomic theory. I might need some spectral data. I might need to know about wavelengths and so forth and things like that. All right, so I've done the chemistry. I figured out what's in this rock. Okay? Now I'm going to justify a method. So I read through this, the 20 pages that matter in that 300-page report, which are the deflection methods, and our students analyze that and say, hey, what do we think about this method? What about this method? What are the costs of this method? Let's set a timeline. This is the actual timeline they have as to if we detect an asteroid that's going to hit Earth, what we would need to do it. And so they can set out that timeline. And then we say, hey, what physics do we need? Is that going to be an impact enough? And so you teach the physics of it. You teach that this kinetic impactor hits that asteroid. Is that going to be enough? And then once you get that calculation, that number is going to be important. You plug it into a simulation and you see, hey, do you live or do you die? And if you die, you start over, right? You start the process over and justify something else. So obviously we're not there yet because you see there's a lot of interdisciplinary areas, but I think this is so powerful. If science became something like this, where you have a problem, that's the problem, and you learn whatever you need to solve it, right? Because engineers, for example, they don't say, hey, I know gas laws, so I'm going to look for every problem that I can solve with gas laws and just solve those problems, right? They get that problem first up front, and then they say, what do I need to learn to solve this problem? And if we can make that shift in science and making it a problem first thing, and then thinking about what we need to learn to be able to solve that problem, I think it opens up so much more enriching types of lessons and so forth. All right, just a few pieces of feedback for my students. We'll look at the positive feedback good, and then we'll run out of time for the negative. No, okay, we'll show the negative ones next. Okay, so the positive ones, here's what students say. It said, it's an aesthetic choice that gives everything context and meaning. You're learning with a purpose, albeit a fictional one, but nonetheless a purpose. And I think that kind of sums it up. It's like, hey, this is fake. I know it's fake, but at least I feel like I'm doing something. Right? And that's often what video games are, right? We feel like we're doing something. In the real world, am I doing anything? Well, not really. It's all in that virtual world, but I still feel like it. This one. So I have grown to enjoy the space theme. So this person probably gave it like a 0 on the first day. She was probably the one's like, this is going to be stupid. But she grew to like it, and she got a sense that she was a member of the galaxy. What? Okay, so like, I don't know
it might be exaggeration, but like they really do feel a part of something bigger here, like a member of the galaxy. And I apologize for the spelling. I just took them and they kind of typed like they text. So this was on a Google Doc. This person takes her decisions very, very seriously. So she feels, or he, I forget because this was random, the need to answer accurately, to make decisions. And now I'm off course. All right. So this is a person who probably would have given the 5 at the beginning. Space geek. Needed to work on the English a little bit, but felt engaged, saved from absolute defeat. Like he or she was in a green screen room, and we were space masters, whatever that means. All right, it's relatable. This person also didn't like space. Personally, don't like anything spacey, but it does make learning interesting. Smiley face. Everything better, and it blends in. And they really like the commander names that we all have together. So I think the thing you see is that they feel like they're part of something bigger. And for my students, and I'm sure all students, but mine in particular, like their backgrounds are so tough, and if they can feel like they're a part of something, like I feel like that might be more important than any of the chemistry I actually teach them. Some mixed feedback. I think it's pretty cool. But then I get so into the theme that I'll always be asking, Mr. King, did that happen in real life or did you just make that up? And most of the time the answer is, I just made that up. But, okay, it doesn't really matter. And it's good for them to think about that because science literacy is also all about, hey, did that guy make that up? Or is that actually a legitimate thing? So I thought, whoa, that's kind of cool actually, even though this person's really frustrated with it, clearly. Yeah, okay. I don't like it that much because it makes me feel like an elementary school student. It was okay, and after a while it started to get boring. So that's the case where it kind of just died in the middle of the year. It's like, yeah, we're doing everything space. And I was like, oh no, how do I make this space related? And so it kind of died down, but I'm working this year in the second half to make sure that doesn't happen. And some people, students kind of like, see through it, like, oh, there's this guy talking. It's again not the same at the beginning of the year, and we lost the theme throughout the year. So all these comments suggest that they would like it if I were better at it. Is basically what they're saying, which is true because this is the first few years that I'm doing it. And so that's just kind of the results, and that's what the students had to say. So that's it from me. Here is my information. So I actually recently started using Twitter. I didn't really get it before, but now I'm like, oh, this is really pretty cool. There are a lot of wonderful people on Twitter who have a ton of resources. If you don't like Twitter, you can email me at actcommanderking@gmail.com. Everything is Commander King related. I've really taken on this persona, I guess. This is a little bit hard to read, but I think I'll also post it on Twitter or you can email me for the link. But the short link is bit.ly/1FZUF7M. So if you have any questions or you want to just take a look at the other missions that are available there, please take a look. Otherwise, thank you for becoming members of ACT, and I really appreciate your coming back.